Hi, my name is Swetha Theru, and today I'm going to be teaching you on how to solve quadratic equations with different methods. First, let's talk about quadratic equations. What is a quadratic equation? It is a polynomial equation of the second degree that represents a parabola. It should contain at least one term that is squared, and the standard form of a quadratic equation is ax squared plus bx plus c is equal to 0. This is when a, b, and c are constants or numerical coefficients, and x is the unknown variable. One absolute rule for quadratic equation is that the first constant a can never be 0. Let's talk about the vertex form of a quadratic equation. The vertex form is a times x minus h squared plus k is equal to y. This is when a, h, and k are constants, and x is the unknown variable. hk is the vertex of the parabola. X is equal to h is the axis of symmetry. H represents a horizontal translation, which is how far left or how far right a graph has shifted from when x is equal to 0. K represents a vertical translation, which is how far up or how far down the graph has shifted from when y is equal to 0. A in this equation represents the stretch, compression, and reflection factor of the parabola. A quadratic equation can be solved in any one of these following three methods. It can be the quadratic formula method, the factoring method, or the completing the square method. To solve a quadratic equation, I have gotten a sample quadratic equation. In standard form, it is x squared plus 4x plus 5 is equal to 0. As I said before, ax squared plus bx plus c is equal to 0 is the standard form. And for the vertex form, it is x plus 2 squared plus 1 is equal to 0. From this, we can see that negative 2 and 1 is the ordered pair for the vertex of the quadratic equation in the parabola. This is the table of points for the sample quadratic equation that I've chosen, which is x squared plus 4x plus 5 is equal to 0. And these are the ordered pairs used to plot the parabola of the equation. And from this, we can see that the x value can be plugged in as the x value in the equation, and then we can get f of x, which is y. An example could be 0 as x, and we can plug it into the equation, and that would make 0 squared plus 4 times 0 plus 5 is equal to 0. That would make 0 plus 5, which will get us 5. From this table, we can see when we get 0 as x, we get y as 5. From this graph, we can see that the parabola does not touch the y-axis, which shows that there are no real roots. However, there could be imaginary roots. From this, we can also see that there's a y-intercept, which is 0, 5, and the vertex of this equation is negative 2, 1, and the axis of symmetry is negative 2. Now let's solve the quadratic equation that we have gotten with the quadratic formula. The quadratic formula, as you can see here, is x1 or x2 is equal to negative b plus or minus root of b squared minus 4ac over 2a. In the sample equation, a is equal to 1, b is equal to 4, and c is equal to 5. When we substitute these values in the formula, it is negative 4 plus or minus root of 4 squared minus 4 times 1 times 5 divided by 2 times 1. This simplifies to negative 4 plus or minus root of 16 minus 20 over 2, and that gets us negative 4 plus or minus root of negative 4 over 2 times 1, which will get us negative 4 plus or minus 2i divided by 2, and it will get us x1 or x2 is equal to negative 2 plus or minus I, and it will get us the two solutions, negative 2 plus I or negative 2 minus I. The I in this solution represents imaginary numbers, which are complex numbers, and I represents the root of negative 1. Before, we were taking the root of negative 4, as you can see here, and you can't take a root of a negative number. So instead, since 4 is a root of 2, you would multiply 4 times negative 1 and take the root of that. And since the root of 4 is 2, and I is equal to root of negative 1, we get 2I as you see above, and that gets us the 2 roots here. So for this equation, the zeros would be negative 2 plus I, 0, and negative 2 minus I, 0. To verify the solutions that we found from the quadratic formula, we would plug in the x values into the equation. That would get us negative 2 squared plus I squared plus 2 times negative 2 times I plus 4 times negative 2 plus 4 times I plus 5. This would simplify to 9 minus 9 minus 4I plus 4I, which would get us 0. This shows that one of the zeros is negative 2 plus I, 0. Now let's verify the second solution that we found. We would do the same thing as we did last time and plug in negative 2 minus I as the x value, and we would simplify, and overall we would get 0. This shows from our verification that these two solutions, which are negative 2 plus I, 0, and negative 2 minus I, 0, are the two zeros of this equation, x squared plus 4x plus 5 is equal to 0. And to find the y-intercept of the given equation, we would substitute 0 as x and put it in the equation, which would get us 0 squared plus 4 times 0 plus 5, and that would get us 5. Therefore, 0, 5, the ordered pair would be the y-intercept of the quadratic equation, x squared plus 4x plus 5 is equal to 0. Now let's solve the same sample quadratic equation with the complete the square method. We would do this first by making x squared plus 4x plus 5 equals 0 as the first equation, and we would subtract 5 from both sides of the equation, which would get us x squared plus 4x equals to negative 5. Then we would find b over 2a squared and add it to both sides of equation 2. This would get us to 4 over 2 times 1 squared, which would get us 4. We would add 4 to both sides of the equation of equation 2, and we would get x plus 2 squared is equal to negative 1. And we would take the root of both sides, which would give us x plus 2 is equal to plus or minus root of negative 1. You would always have to remember the plus or minus, because when you take a root of something, it will be plus or minus, which would get us x equals plus or minus root of negative 1 times 2, and that would equal x is equal to negative 2 plus I, or x is equal to negative 2 minus I. As I said before, I represents root of negative 1, and we were taking the root of negative 1 here, so we would get I. So the zeros of the sample equation would be negative 2 plus I, 0, and negative 2 minus I, 0. Thank you so much for listening to my lesson on how to solve quadratic equations with different methods. Thank you.